Raise your hand if you've known someone who's had cancer. Now, keep your hand raised if that person was a family member. Keep your hand raised if the doctor told you to be more vigilant about getting genetically tested because of the risks associated with family history. Mostly my family. Now, raise your hand if you know what BRCA, more commonly known as Brava, is. Thank you. 5 years ago, I was in the same boat as most of you. I also didn't know very much about the topic until my mom was diagnosed with stage 3 breast cancer in 2014. Now, at the time, I was a bit worried, but not too concerned. My mom was the epitome of a superhero to me, able to accomplish anything set in front of her. I assumed that beating cancer would just be another thing to check off on a long list of accomplishments. As you can tell, at the age of 13, I was pretty naive. Now, the first time I was genuinely concerned after her diagnosis was when doctors told me that I would need to start getting mammograms and x-ray the breast tissue at the age of 28, when most women don't begin these checkups until after the age of 40. I had no idea why I would need to start getting these tests so early, nor what my risks of developing cancer actually were. I knew there was an association with family history, but I didn't know much more than that. Around this time, doctors also asked me to get genetically tested for what they referred to as specific markers. When I asked for more information, I was brushed aside. I was 13 years old. So I was confused and afraid. So I began to do some research to try to better understand my situation. And I figured out that doctors may be testing for something known as Brava, which is a genetic mutation that severely increases a person's risk for breast, ovarian, and prostate cancer, among others. To give some quantitative context, about 12% of women in the general population will develop breast cancer by the time they turn 80. But if you BRCA, that number reaches about 70%. The statistics regarding ovarian cancer are similar. About 1.3% of women in the general population will develop ovarian cancer by the time they turn 80. But if you BRCA, that number is anywhere from 17% to 44%. Now, that's a whole lot of statistics, but my mom wasn't an outlier. In March of 2016, she passed away from BRCA-induced triple-negative breast cancer. So let's rewind back to that time in 2014 when I was still hopelessly naive and trying to figure out what was going on. And I started researching genetic testing. Here's what I found out. You have to start with genes. What are genes? So they are fundamental building blocks of characteristics and heredity that are organized into chromosomes. All in all, you have 23 chromosomes, 23 pairs of chromosomes, one from each parent. And put together, those have about 20,000 genes. This is referred to as the human genome. Now, this is your entire genetic code. Each time you grow and age, your cells can divide. And this leaves the opportunity for a mistake or a mutation to happen. Think of this as a typo. Now, the typo can either be harmless, the sentence still makes perfect sense with or without it, or it can be beneficial. So the sentence is actually better understood with this typo. So a harmless typo would be something like having different colored eyes, while a beneficial typo would be something like having better than average eyesight. Or the typo can be harmful. The sentence gives off a completely different message than was originally intended. This would be something like having Down syndrome. And these mutations are where we get genetic variation from. So once scientists figured out these topics, they began to wonder what each of the 20,000 genes a human has is for, because it's pretty difficult to come up with 20,000 characteristics of a human off the top of your head. So in 2003, the Human Genome Project was completed as a way to find the answer to this question. This international project sequenced the entire human genome and mapped out every single gene, both physically and functionally. So we now know the purpose of each gene. When you send out your genes to get genetically tested, they get compared with this template that scientists have developed. And this way they know if a mutation they find is something as simple as having blue eyes instead of brown, or something more serious like a BRCA mutation. So what is genetic testing? Well, it's a medical test where you send out all or part of your genome to be sequenced, and scientists can find changes or anomalies. These changes or anomalies can be genetic conditions or disorders, or they can be used to find the chances of passing on those conditions or disorders. So many of you have probably heard of 23andMe. This is a service that you buy online for about $150. The package gets shipped to your house. You spit into a tube, send the tube back to the company, and in a couple weeks you're able to access a wide variety of genetic information online, anything from your ancestry to fun facts, like if you get annoyed by people chewing with their mouth open, which is actually a genetic condition, fun fact, or more serious things like BRCA mutation. So here in Toledo, Promedica Genetics has a similar process, but they focus more on the cancer genes, so it's a bit different. You meet with a genetic counselor to go over family and personal history, so they can decide what parts of your genome should be sequenced. Then you get your blood drawn in the next room over, and in a couple weeks you meet with the same genetic counselor to go over your results. And they let you know if any further steps need to be taken. Now, we use this technology in a similar manner at the research lab I work in at the University of Toledo. So we study this protein called MAB1, which is associated with a tumor suppressor gene. So a little bit of background first. MAB1 helps with cell division. And when cell division doesn't go correctly, cells can develop aneuploidy, which is this characteristic of having an unusual amount of chromosomes. The reason why this is important is because a lot of solid cancer tumors are made of cells with aneuploidy. So right now in the lab, we are trying to mutate the protein and observe its behavior. Throughout the process, we use this company called GENEius, which allows us to send out the DNA we've extracted from the protein and sequence it to make sure we're studying the protein we want. Now, the reason why this is important is because we want to learn to control this protein, so in theory, we can control the existence of solid cancer tumors. And without this technology, this process would be near impossible. So, in addition to the benefits we get from using this technology in a lab, there are so many benefits to using this technology on us. First, it is almost completely, if not 100%, painless. Second, most health insurance plans will cover genetic testing and genetic counseling, especially if there's a history of genetic disease or cancer in the family. Third, with the Genetic Information Non-Discrimination Act, otherwise known as GENA, Americans are protected from discrimination based on their genetic information in both health insurance and employment. Health insurers cannot make decisions like setting premiums, determining eligibility or coverage based on genetic information. Employers cannot make decisions like hiring, firing, promotions, job assignment, pay on any kind of genetic information, and they also can't ask or even require you or your family members to be genetically tested as a condition of employment. Now, there are some disadvantages to genetic testing that shouldn't be ignored. So first, even with GENA, long-term care insurance, life insurance, and disability insurance can make decisions based off of genetic information. Second, some people have reported feeling guilty or anxious after seeing the results from their genetic test. But when you meet with a genetic counselor, this is one of the things that they really re-emphasize. So they ask you questions about what you think your reaction would be to seeing a result of something like having BRCA, to make sure that they can better counsel you through the process. And they reiterate the fact that no matter if you use a service like Promedica Genetics or 23andMe, there are so many resources available nowadays to deal with any kind of information you need to learn. Third, and the one that confuses me the most, services like 23andMe can be required through a court order or a subpoena to give genetic information to law enforcement that would lead to a conviction that may not otherwise have been possible without your genetic information. My response to this is very simple. Don't commit crimes if you want this problem. In all seriousness, there are so many benefits to being genetically tested. No pain, no cost, no discrimination. And arguably the most important, the ability to make more informed medical decisions. Anything from knowing what kind of monitoring you need and when, such as when to start getting mammograms, to knowing the chances of your children, hypothetical or not, having certain disorders, to being able to know exactly what kind of genetic disorder you may have, can all be learned through genetic testing. I want to leave you with a final question. If you were handed on a silver platter a way to make more informed medical decisions leading to a longer and healthier life, would you take it? For my mom, getting genetically tested earlier on in life could have saved her life, and it can save yours too.